Hello guys, I am Siddhan. Welcome to my YouTube channel. In this video, we are going to see about what is nanomaterials and how the nanomaterials are classified and what are the approaches to synthesize nanomaterials and the applications of the nanomaterials. Let's move on to the video. Hmm. First of all, nanomaterials. Before getting into the topic, I would like to give a small introduction about nanoscience. Nanoscience is the study of incredibly small scale that is not visible to the naked eye, okay, in the nanometer level. Yeah, and this nanoscience involves various fields such as physics, chemistry, biology, and material science. And the nanoscience has the potential to revolutionize the industries such as healthcare, electronics, and the energy field, etc. Okay, the nanomaterials. Nanomaterials are the materials that have structural components with one of its dimensions in the range of 1 to 100 nanometer. This 1 to 100 nanometer is called as a nanoscale, nanoscope, or nanometric range. In fact, the nano word comes from the Greek mythology, and the nano means small or dwarf, so, which is very small. Okay, in fact, 1 nanometer is a billionth of a meter. That is 1 nanometer is equal to 10 power minus 9 is equal to 10 Armstrong. And the figure 1, this is the nanometer range of the materials. For DNA, it is a 2.5 nanometer. On water molecule, it is a 0.2 nanometer. These are the materials which is present in our body, that antibody and the fungus spores, coin, human hair, and RBCs. And these materials are the man-made materials: graphene, carbon nanotubes, fluorines, methyls, surfactants. Okay, these are the examples for the nanomaterials examples and their sizes. And this nanomaterial shows unique properties compared to bulk materials. Like when it comes to nanomaterial, their properties changes like increased strength, toughness, hardness, ductility, melting point, efficient electrical properties, magnetical properties, catalytical property, and optical property, and so on, as compared to bulk materials. And then next, classification of nanomaterials. The nanomaterials classified based on various ways. For example, dimensions, electrical property, and the magnetical property. This figure 2 shows the classification of nanomaterials based on their dimensions. Okay, first, based on dimension, how the nanomaterials are classified. It is classified into four types. That is a 0 dimension, 1 dimension, 2 dimension, and 3 dimension nanomaterials. The 0 dimension nanomaterials means all the three axes are comes under all the three axes x, y, z. These three axes are comes under the nanoscale range. That is said to be 0 dimensional material. For example, carbon quantum dots, and then fluorines, uh, gold nanoparticles, liposomes, core cells. These are the example for 0 dimensional nanomaterials. For 1 dimensional nanomaterials, any one of its dimension is out of the nanoscopic range. That is said to be 1 dimensional nanomaterial. For example, carbon nanotubes, zinc nanorods, and the nanofibers. These are the example for 1 dimensional material. For 2 dimensional material, any two of its dimension is out of the nanoscopic range. That is said to be 2 dimensional material. For example, graphene sheets, MXN sheets, van der Waals. These are the good examples for 2 dimensional material. For 3 dimensional material, all the three axes are out of the nanoscopic range. It forms the 3D like structure. That is said to be 3 dimensional material. For example, graphite. It is a 3 dimensional material, and then 3D metal organic framework material, and then dent trimmers and the polymer matrix. These are the good examples for 3 dimensional materials. And then based on electrical property, they are classified as conducting, superconducting, and non-conducting. The conducting nanomaterial, for example, silver, copper, gold, graphene. These are the good examples for conducting nanoparticle. For superconductivity, it is also known as semiconductors. For example, silicon nanowires is a good example for superconductivity, and then germanium nanoparticle and zinc oxide nanoparticle. For non-conducting, it is an insulator. Example, alumina, silica gel, and then polymer based materials are a good examples for the non-conducting nanomaterials. and the materials also classified based on their magnetical property. One is magnetic nanoparticle and the other is non-magnetic nanoparticle. The example for magnetic nanoparticle is a ferrite based materials. Ferrite based materials are the very good examples for magnetic nanoparticle. For example, iron oxide, FeTO3, and then cobalt oxide, and then nickel oxide. These are the very good examples for magnetic nanoparticle. For non-magnetic nanoparticle, example, gold nanoparticle is a very good example, and then polymer based materials are very good examples. And the next, approaches to synthesizing nanomaterials. There are two type of approach when it comes to nanomaterial synthesis. One is a top-down approach and another one is bottom-up approach. For top-down approach means breaking down the materials from bulk to powder, and it forms the nanoparticles. This is said to be top-down approach. In top-down approach, there are lot of techniques used in this nanomaterials, and one is mechanical milling. It uses high energy ball milling to break down materials into nanostructures. Okay, and the another one is lithography. It uses photolithography and electron lithography for precise nanoscale patterning. And the another one is laser ablation. It uses high laser plasma to create nanoparticles from bulk materials. And the etching, it uses chemicals and plasma to remove layer from the bulk material to form nanoscale features. And then electrospinning, it produces nanofibers by applying high voltage to the polymeric solution. Okay, and then high pressure torsion is the uses of extreme pressure and shear force to refine grain size at the nanoscale level. This is said to be high pressure torsion. And the another approach is a bottom up approach. Bottom up approach is the building up of materials from atom by atom, molecule by molecule, or cluster by cluster to form nanoparticles. In this image shows the how the bottom up approach works. Was a precursor containing molecules, that is atoms or molecules or clusters, and then formation of ions, radicals, and electrons, and then condensation and forms of clusters, and then nanoparticle synthesis. Using bottom up approach, there are a lot of techniques to synthesize nanomaterials. The one is Sol-Gel method. Use uses chemical reactions to form nanomaterials from the precursor solution, and the chemical vapor deposit the thin films of nanostructures using gaseous reactants and the other is physical vapor deposition. It involves evaporating and condensation materials to create nanoscale coatings. And then molecular beam epitaxy is the highly controlled method for growing nanostructures layer by layer. And the other one is a spray pyrolysis. It converts liquid precursor into a solid nanoparticle using high temperature. And the other one is self-assembly process. Self-assembly process uses the intermolecular force between the atoms to organize nanoparticles to form ordered structures. Okay, and the other one is wet chemical synthesis. It is also said to be co-precipitation method. Involves chemical reaction to produce nanomaterials. And then hydrothermal and solvothermal synthesis, it uses a high pressure and high temperature to grow nanomaterials from a precursor solution. This is the bottom up approach. And application. Nowadays, nanomaterials are used in wide range of applications. For example, medicine, clean energy, sensors, food, cosmetics, clothing, and sport equipment. These are some of the major areas where nanomaterials seems highly applicable are listed below. These are the highly applicable applications. One is electronics and non-electronics. In mobile phones, we are using nano chips nowadays, and then nano sensors. This is the sensing for opening mobile phones. and thermal sensor also we are using on the food and agriculture industry and personal care products and consumer goods such as face cream, sunscreen. Here, zinc nanometals used for those materials, and in automobile industries, wastewater treatment, the environment, medical diagnosis used to deliver the drug for certain place of our body, and then textiles and paints, energy sectors like batteries, supercapacitors, fuel cells, and fuel cells and the solar cells, and in the even in space applications and the structural applications, nanotechnology in defense also nanotechnology is used, and so on. These are the uh, wide range of application of nanomaterials. I hope you understand this video. If you have any doubt, comment me in the comment section. In the upcoming video, I would like to share about how to synthesize nanomaterials, and after that, we getting into the characterization techniques. Okay, thank you for watching the video. Thank you.